99% of the information that we determine from objects in the universe comes to us by analyzing the light that we receive them. Since light propagates as a wave, let's begin by analyzing some basic wave properties. We will call them basic wave parameters. And the four parameters that we will understand now is first the wavelength. The wavelength of the wave, and we usually designate that by the Greek letter lambda, which is spelled lambda. And the second parameter that we will understand is the period. And we will call that by the capital letter P. And the third is the frequency. And for that we use the Greek letter nu, which is pronounced nu. And the fourth is the speed with which the wave travels. So I want to understand these four basic wave parameters, wavelength, period, frequency, and speed, by analyzing what happens if you have the surface of a pond and you drop a stone into the pond. Then what happens is that ripples propagate outwards from the point of location, and the ripples indicate a high part of the water, then there's a low part of the water, then a high part of the water again, and these ripples propagate outwards with a certain speed from the point of impact of the stone into the pond. And you notice that in this pattern there is a certain distance between the crests of the waves, which we identify by the Greek letter lambda, standing for wavelengths, and that the wave propagates outwards with a certain speed, which we will call v, capital V, not to be confused with nu, which stands for the frequency. So the speed of the wave propagates outwards with a speed v, and the distance between two crests is known as the wavelength lambda. Now what I want to do is just take a slice of one of those waves coming out, not using in 3 dimensions anymore, but just in 2 dimensions, and see what we find when we do that. So we will now just take the wave coming out, and it is traveling forward in this direction. And as indicated, the distance between any two similar points on the wave, be it crest to crest, is the lambda, or you can also go from low point to low point, it's the lambda, or you can also go from the beginning of one wave to the beginning of the next wave. So any two similar points on the wave is designated as the wavelength. Now the wave is traveling forward, and if you are standing perhaps at this location right here, then the wave has not yet reached you. So if we wait a little while, then the wave will have reached you, and then the picture will look like this. And now the wave, well, let's draw you in the same place, and you are standing here, and now the wave has just reached you, and it is traveling in this direction. And now if we wait just a little bit longer, you're still standing in the same place, then one wavelength has passed you by, and the rest of the wavelength is still coming in your direction. So now one wavelength has passed you by in a certain amount of time. The amount of time that it takes for one wavelength to pass you by, we designate as the period of the wave. It's the amount of time for one wavelength to pass a fixed point. It's the period of the wave. So now we have introduced the wavelength, which is the distance between any two points, similar points in the wave, and the period, which is the amount of time that it takes for one wavelength to pass a given point. Now it's easy for us to find the speed of the wave, which we designate by v, because it's always distance that something travels divided by the time that it takes to travel it. In this case, the wave is traveling one wavelength in period p. So the velocity of the wave, the speed of the wave, is given by the wavelength over the period. Now, let's examine one more. That you are standing here, and the first wavelength has passed you by, and then after some time, there are other wavelengths that pass you by, and other wavelengths that pass you by, and other wavelengths that pass you by. So you count the number of waves that pass you by in 1 second, and that is known as the frequency. The frequency is the number of waves that pass you by in 1 second. So frequency equals number per second. And it's also understood as a frequency in other acoustic waves. For example, if you're beating on a drum, then the frequency with which you beat is the number of beats per second. So frequency is beats per second. Now, there's a relationship between frequency, which we know as mu, and period, which we know as p. And I will illustrate that to you with some very simple numbers. If the period of the wave is 1/10 of a second, that is, the amount of time for one wave to go by is 1/10 of a second, then how many will go by in 1 second? I hope you decide that 10 will go by. Now, if the period of the wave is 1/3 of a second, then how many do you think would go by in 1 second? I hope you also arrive at p. So you see, there is an inverse relationship between the frequency and the period. So the frequency is 1 over the period, and the period is 1 over the frequency. This is how these two are related. So what we've done is illustrate our 4 basic parameters of a traveling wave: the velocity with which it travels, the frequency, that is the number of waves per second that pass a given point, the period, the amount of time it takes for one wavelength to pass a given point, and the wavelength itself, which is the distance between any two similar points on the wave.